Okay, there we go. So, so I'm going to say solve for x by completing the square. Okay, we were doing this last week. So completing the square is just a method to solve a quadratic. We know how to factor. That's another method to solve a quadratic. We can use square roots as another method. Today we're going to look at quadratic formula. So we have a lot of methods to solve. A lot of it just depends on kind of the setup and which is going to be easiest. But in that process, let's do completing the square with this equation. I'm a little crazy last period, so hopefully I don't go crazy. I'm going to move my camera a little bit, but I'll do that in a minute. Okay, so we like to do things with numbers. Numbers are fun, they make sense, you can put them in calculators. But we know in algebra, anything we can do with numbers, we can do with variables. Wow, this is so exciting. So let's go through our steps. So this is my equation. We said for completing the square, the coefficient of x squared has to be 1. So we don't want an a there. So the first thing I'm going to do is divide everything by a to take care of that. Just like if that was a 7, you divide everything by 7. We're using a variable, why not? So that ends up being x squared plus b over ax plus c over a equals 0. So now we at least have, that's taken care of. But let's get it into the actual setup that we need as well. We want the constant, c over a, on the right side. So I end up with x squared plus b over ax plus blank, right? We add that blank to complete the square, equals negative c over a plus blank. So I'll give you I'll try to pause after each step, just because I know it's kind of a lot of writing. Okay, so then the next thing we always did to actually complete the square is we took whatever was here, we divided it by 2, and then we squared it. So I can write this as, sorry, the hiccups, I was like chugging water now. If I'm dividing that by 2, you're multiplying by 1/2, and you can just write it as b over 2a. So the 2 just means you're dividing it by 2, and then we square it. So you always divide it by 2 and square, and then whatever I put here, I have to put here as well. Okay, so feeling pretty good about life, I guess. I don't know. It's kind of, once again, it doesn't feel natural with the variables, but you'll see the magic that happens in the end. At this point, I like to I'm going to actually square these, just so I don't have things squared the whole time. So I'm going to write it as x squared plus b over ax plus, I'm just going to square everything in that parentheses, and that would be b squared over 4a squared. So just everything gets squared. And I'm going to do the same thing over there. Okay, just so we don't have parentheses and it's not all messy looking. So once again, not the nicest looking, but we're just going to keep chugging along here. In a minute, I'm going to factor the left side. That's the whole reason we do this, to factor the left side so we can take square roots. Before I do that, I just want to simplify this side. I want to make it have a common denominator. So that when we do need to combine it, it makes life a little bit easier. In this case, the common denominator would be 4a squared, right? Because then everything's represented. So this would just stay the same, but this I'd have to multiply by 4a. So I'm going to write that as minus 4ac. Ooh, that's looking a little familiar if you remember the quadratic formula. So now that side's kind of like a little bit cleaned up. We have fractions, but they have common denominators, so that will make it easier. Let's factor this side. So when I factor, since this is a perfect square trinomial, you take the square root of the first term, which is just x. Keep that sign. You take the square root of the last term, so you just basically take the square root of each individual thing. So that would be the square root of b squared is b over, and then the square root of that's 2a. All right, so we're feeling semi-good. It's starting to look kind of quadratic formula-esque. So we just need to kind of clean up a few things. So at this point, I'm just kind of moving over here so I have some room. I'm not squishing in the bottom here. I'm just gonna rewrite this as x plus b over 2a. I'm gonna take the square root in a minute. On this right side, I'm just gonna make that one fraction over the common denominator of 4a squared. And just to be fancy, instead of writing it as negative 4ac plus b squared, I'm gonna write it as b squared minus 4ac. So that's definitely looking familiar from the quadratic formula. I just kind of flipped the order just so it looked a little nicer. All right, let's take the square root. X plus b over 2a equals plus or minus. I can't do anything to the numerator, so it just stays as the square root of b squared minus 4ac. I can take the square root of the denominator though, so that's why I kind of have it on its own, because that's a perfect square, and the square root of that's just 2a. All I have to do is move this constant over here. Sorry, I'll slow down after this step. I'll kind of stop. I'm just rewriting it, and I'll stop to give you a minute. Sometimes I get excited, and I just can't go any slower. Okay, so I'm going to stop here for a second. I'll be right back. So once again, I'll kind of just talk through the steps if you're still writing. So we got to here, we factored, we're feeling good. The whole reason we factor is so we can take the square root of each side, which I did here. So once I do that, that kind of cancels the squared. I'm just left with the left side. On the right side, I took the square root, so you need to put the plus minus. The square root of the top, I just kind of leave as the square root of the top. But the square root of the bottom, I can simplify, so that's why there's no more square root in the denominator there. And then from here, I'm just trying to get x by itself, so I'm moving that to b over 2a by subtracting it. And then magical, since these are like denominators, you can write it as one big old fraction, negative b plus or minus the square root of b squared minus 4ac, with the whole thing over 2a. And that, my friends, is the quadratic formula. So if you can imagine, back in the day, someone thought that was fun to do that. Like, they just in their spare time were like, hey, let's go for it. And they came up with this new formula. And I'm thankful to them, because I like the quadratic formula because you can plug anything into it. There's no restrictions, like factoring, not everything's factorable. Square roots, not everything has the correct setup. I mean, completing the square just gets highly irritating if you have weird numbers. So quadratic formula works for anything and everything. It solves every quadratic, which is a delight. But that's kind of where it came from. So don't just trust your teachers when they tell you that's why. Make them show you. So there you go. So we took some of the completing the square, used that, and then we magically came up with that. So with that being said, last week we did a lot of completing the square with numbers. You do not need to memorize this. This is just like for fun. You guys don't think it's fun, but there you go. But in general, as you were working last week, I did try to put up answer keys. Hopefully you kind of look through and get a general idea if you were doing things correctly. Before we move on to doing some quadratic formula problems, does anyone have any questions on completing the square? Anyone at home, feel free to chime in. I'm just like standing in front of the camera. Okay, so we'll do a little more practice this week. There's no assessments or anything planned for this week, basically, because me and Mrs. Keesley just didn't want to correct them. I'm going to be honest. Like, the end of the term gets a little crazy, especially with trying to catch up with people and just people being out so much. So we'll just kind of ease into the end of term 2. When we do have an assessment, probably next week at some point, it will be on term 3. So just as a heads up there. If you see anything this week you're not getting, I'll kind of leave time every day for questions. So I know when we do like a lot in a row, it gets a little overwhelming, but everything's kind of related. So hopefully that's not too bad. But please come in with questions anytime you have them. And don't sit there and be confused, because that's just plain old silly. So what we're going to do is a quadratic formula problem. How exciting. Let me see if I can remember the numbers I used last period, because those were delightful. Oh, I did remember them. Okay, good for me. So we're going to solve something now using the quadratic formula. Now remember, sometimes there's multiple methods you can use. We'll focus on quadratic formula for now. But later, when we talk about the problem set, there's a whole section that just says solve it using any method. So if you have a preferred method, go for it. But for this one, we are going to solve using the quadratic formula. All right, let me write that bad boy down. Formula. We'll kind of keep it simple with the setup. It was x squared plus 6x plus 12 equals 0. So you might be thinking, like, I could complete the square. Yeah, you could complete the square. It's a quadratic. Sure. We're going to use quadratic formula just to kind of see some things that pop up. So I chose these numbers for a reason. So first thing, know what you're plugging in. Your a, b, and c come from your coefficients. Make sure your equation is equal to 0. So that's a big thing. In standard form, equal to 0. So in this case, your coefficients, a is 1, b is 6, c is 12. And we just start plugging in. Let me actually write the formula in case you forget it, or it's been a while. I know we just found it, but. So I start to plug in. I have negative b plus or minus. Underneath my square root is b squared minus 4 times a times c. And then that whole thing is over 2 times a. I'm just going to think where they need to be. From here, I just grab my calculator and simplify under my radical. So just write my radical. I do 6 squared minus 4 times 1 times 12. So try it on your own. Just make sure you know how to use your calculator. At this point, like we assume you guys can do basic math. It's just it takes forever sometimes, so calculators are your friend. So when I find underneath that radical, it comes out to negative 12. So just make sure you can get that. Okay, so we're already looking way better. Here's where you just need to make sure you're okay with the simplifying part. So when you get to here, you want to always check your radical and see, can I simplify this? And I can. So just off to the side or in your head or wherever, just remind yourself there is a negative, so I'm going to have an I. And I can break down root 12 onto 2 root 3. So we're going to replace this with 2i root 3. Okay. So always check your radical. Sometimes you're just like, if it's the square root of 13, you're just done. So I feel like sometimes you want to keep going. If it's not possible, you're just kind of stop and that's your final answer. But in this case, we simplified. Okay, we're feeling a little bit better. But we also want to see, can we reduce this fraction? So to reduce it, basically ignore the radical, because that's irrational. But look at your rational numbers and see, is there anything that they have in common that we can reduce? And these are all divisible by 2. So we are going to reduce that, and it comes out to negative 3 plus or minus 1i, or you could just write I root 3, and that will be over 1, so you don't even need to write that. And that would be your final answer. We're going to give all of our answers in terms of a radical, like reduced radical. We don't want decimal answers. We'll only do decimals for word problems, so just as a heads up there. I was just making sure I was like still on the screen. Okay. Aggressively looking over there. So for now, technically that is my 2 answers because the plus or minus kind of gives me both instead of having to write it twice. And at that point, I can't really simplify or combine anymore. So right now, does anyone think they have any questions about plugging into the quadratic formula or simplifying? Do you guys remember this from last year? I feel like they like you did a lot last year. They're really aggressive with it. All those algebra 1 geometry teachers. Okay, so here's what I'm going to do. I'm going to go to the hardest problem. We're just going to get it over with. Because then from there, everything will seem easier. So let's just do the hardest problem. We'll just get it over with. It's in the packet. So you might want to just do it in your packet. For you at home, if you have the packet printed, great. If not, you can just do it on a separate sheet of paper. So then it says quadratic problem set. So we're using the quadratic formula. Let's just do the craziest one there is. It's number 19. It's one of those ones where if you were working on your own, you got to, you'd be like, what the heck is going on? There's eyes. I don't know what to do. Just because it looks different, let's just go over it. Not all of them are like this. Once again, this is one of the more difficult problems. So I look at this and I say solve the quadratic formula. I'm like, oh, first I need to do is put it in standard form. So we're gonna we're gonna cross multiply and distribute. So I'm gonna kind of take this and cross multiply, and we'll kind of distribute through. So 2x times x is 2x squared. And then we have 2x times 3i, we write that as 6ix. We always want the x to be like the last thing, that's the variable. So I just represents part of the number. And then we get plus ix, or 1ix, plus 3i squared. Okay, so that brings in a lot of the complex number stuff we did kind of last section. But we do some I'll kind of simplify that in a second, but we did our distributing. Let me just distribute the other way just to kind of get that step over with. So we have 3x times x, that's 3x squared. And then what would I get? Minus 3ix plus 4ix. Once again, x is always going, that's the last thing. And then minus 4i squared. Whew, okay. So bringing in some of that simplifying. So let's just kind of try to neaten this up. We have 2x squared. We can combine these, right? Because they both have ix. So that would give me 7ix. And then just as a reminder from last chapter, section, whatever you want to call it, I squared is actually just -1. So that's just really minus 3. Okay, so that's looking a little better. Let's do the same thing to the right side. We have 3x squared. I can combine those like terms to get me plus 1ix. And then once again, I squared is -1, and then negative times negative gives me plus 4. Okay, so we're already looking a little bit better. We want to plug into the quadratic formula. That's the main goal. This needs to be equal to 0. So let's get everything to one side. I'm going to move everything to the right. I like my quadratic term to be positive. So I'm going to move the 2x squared. I'll subtract that over here. That just gives me x squared, which is delightful. I'm going to move the 7ix. I'll subtract that. God bless you. That gives me -6ix. And I'll move the 3, or the -3. Plus 7. All right. Woo. We're at least now down to like where we need to be setup-wise. So once again, you want an equation in standard form equal to 0. So now let's plug in. Now, as I plug in, my coefficients are my a, b, and c. So a is 1. Right? B.
Jacob Balsamo, please report to the main office. Jacob Balsamo to the main office.
B is -6i, so you need to take the I with it, because it's part of the number. And then C is 7. All right, so let's plug in. So you're going to see it's actually not as bad as it looks. It's just that I kind of throws us off, but we're just doing exactly like we did with regular numbers. Why not? So x equals -b. Obviously, you can, if you just want to turn that positive, go for it. I'm just kind of showing my steps. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Excuse me. All right, So, okay, let's start simplifying. So x is gonna equal double negative makes a positive 6i plus or minus, and I need to simplify under here. But think about what this means. If I have this in parentheses, it means negative 6 squared, which is 36, I squared. Oh, but wait a second, I know that I squared is really negative 1. So that just gives me 36, excuse me, that gives me negative 36 minus 4 times 1 times 7. So it actually kind of ended up working out since we squared it. It became negative 1. It might be a little tricky to do that in your calculator, so that's why I was kind of like reasoning through. And now that I've gotten it to negative 36, I can do minus 4 times 1 times 7. And I did something wrong because I put negative 3 and nothing. And 1 times, how can I not put negative 64? Okay. So I feel like at each step you're like, I don't know if I'm going to be able to do this, but it kind of works out. So just pay attention to those little details. So then at this point I say, oh, square root of negative 64, I can do that. The negative means I'm going to have an I, and I know the square root of 64 is 8, so that's just 8i. And then at this point, if you can combine things, do it. So I can, because these are like terms. So the plus minus is going to give me my two answers. I'm going to do 6i plus 8i over 2. And I'm going to do 6i minus 8i over 2. So the plus minus I'm just splitting up. That will give me what, 14i over 2, which is 7i. And that will be negative 2i over 2, which is negative 1i. And that, my friends, are our two answers. It's perfectly fine to get answers with i's in them. Why not? You can have imaginary. What that actually means, we'll do graphing later, is when we find x-intercepts, they go through the x-axis. So when they're imaginary, it just means you still have a parabola. It's just your x's you're finding are imaginary because they're not actually going through the axis. So it's a little funky. But we'll do a lot of graphing later. But that's what it practically means. It means you're up in the imaginary world. So I started with the hardest one because I said, technically we just plugged into the quadratic formula. There was a little bit extra with the actual setup of it, so just be careful there if you're rearranging stuff. But the plugging in after all that wasn't terrible. Just be careful with those i's because things like that do pop up. Other than that, let me just do, actually, that should be okay, I think. Because I think I did everything. Yeah, you should be fine. All right, so let me just update you on the problem set. The last few we've done, I've kind of checked them day by day. I'm not going to do that just because I know people like have lives. So one day you're busy, the next day you have time and study, the next day, I don't know, you have this or that or whatever. So I'm just going to say we have this problem set. The entire thing is due Monday, which is February 1st, during class. So if you're in cohort A, I'll see you Monday. So you just bring it into class, I'll check it. If you're at home, you just need to scan it at like 1:20. So that kind of gives you an extra like little time. If you have a study during block 2, then you have an extra day to do an in-study type deal. So hopefully that you can kind of make your life work around that. But I know people have to be like uploaded and then be like, I'm like rushing. I know I did them. I don't want you to do them wrong because you're rushing. Like, take your time. At the current moment, I'm actually going to stop this for a second.